Hi, I'm Rob Hornsbo and I'm the Product Manager here at Datapack in Cambridge. Today I'd like to take some of your time to introduce you to the new glass tempering system. I'll take you through the new system, listing some of the features and benefits and the typical applications. And then I'll show you how the system is used in the factory. An interesting example of an application of tempered glass in the architectural environment is this stairwell. Here we can see the aesthetics need to be combined with the strength, and that's why the architect chose to use tempered glass in this application. In this typical automotive glazing application, we can see some of the problems faced by the process engineer. The glass has a black band around the edge to prevent reflections from the edge of the glass, causing distractions for the driver. The problem for the process engineer is that this area will heat up differently from the area of clear glass. Ensuring uniformity of temperature for the tempering process is critical, and that's where the Datapack system can really pay off. What I'd like to do now is go through the components of the Datapack glass tempering system. The system consists of three principal parts: the thermal barrier, the heatsink, and the data logger. What I'd like to do first is go through the features and benefits of the thermal barrier. The TB7528 is the first of a new generation of thermal barriers from Datapack. Truly a unique solution in the industry. The low height and high temperature capability of this barrier are unparalleled. The outer case is constructed from Inconel, and all of the jointing is done by robotic laser welding. This reduces distortion to an absolute minimum, so this barrier, being 29 millimeters high, can pass through furnaces with clearances as low as 30 with absolutely no problem. The outer coating is a plasma sprayed ceramic, and this has two major benefits to the end user. It ensures that even with extended periods of use, the thermal barrier will not oxidize, so the thermal performance will not change with time. In addition, the ceramic coating ensures there's no metal contact with the ceramic rollers within the furnace. This is critical in the glass tempering industry. Any trace of metal left on the rollers could be picked up by product following and cause a problem with product quality. The heart of the glass tempering system is based on the Q18 data logger. This is in use by thousands of customers worldwide in the solar and electronics assembly industries. The DQ1840 features a solid steel case that provides much higher thermal mass, enabling it to withstand the process conditions. In addition, we've recessed the buttons and the LED indicators to protect them when removed from a hot barrier. Fitting between the barrier and the Q18 data logger is an all-new solid heatsink. This is designed to combine thermal mass with rapid cool down, which are both important in this process. The front end of the heatsink, over which the thermocouples pass, has a high temperature mica insulation block to cut down the heat coming from the doors of the thermal barrier through to the data logger. The result of all this design effort is a thermal barrier of only 29 millimeters high that can protect the data logger for up to 10 minutes in a furnace at 700 centigrade. Obviously, with a solution so compact, correct use and deployment of this system is crucial to ensure the best results. So let's look at how the system will be configured for use. Once reset, the QA team will flash the red and green lights whilst waiting for a trigger. At this point, the user will connect the thermocouples, carefully noting their positions on the glass sheet. Once all the thermocouples are connected, the user simply starts the data logger by pressing the Start button. The logger will confirm correct operation by changing from a red and green LED to a green flashing LED. Once confirmed, the system should be placed into the heatsink and slid into the thermal barrier. Care should be taken to route the thermocouples through the slots in the heatsink and in parallel across the insulation block. Once this is done, the top of the heatsink can be placed over the data logger and the system is ready to be slid inside the thermal barrier. When sliding the heatsink into the thermal barrier, first ensure that the doors are fully open. And then the system can be simply slid into position. Then the doors need to be carefully closed, ensuring that the thermocouples are not trapped in the process. Now the glass tempering system is ready to be placed on the rollers and passed through the furnace. When the system exits the furnace, the data logger needs to be recovered from the thermal barrier and the data downloaded to Insight for analysis. This operation should be conducted as quick as possible to prevent the data logger from overheating. The doors are simply slid open and the tool provided is used to slide the heatsink, tray and data logger from within the thermal barrier. Once clear of the thermal barrier, the top half of the heatsink is simply slid off and removed. At this point we can see the green light is still flashing, confirming that the data logger is still operating. Simply disconnect the thermocouples and take the data logger back to the PC to download the information for analysis.